Now let's start with quadrilaterals. Specifically, the dark, sorry. Right on time. So specifically today, we're going to be working with 4 specific shapes, okay? I want you guys to tell me, number 1 there on my table. What is that quadrilateral called? What do we call the quadrilateral number 1 in my table? Anyone? Maybe I should number them. That would be a start. 1, 2, 3, and 4. Number 1 is called a what? Parallelogram. Okay, let's look at the properties that make a parallelogram. A parallelogram. That felt very strange to say, but you guys get what I'm saying. Okay, let's look at it. So we're going to look at properties that relate to diagonals, the angles, and the sides of every shape. It's okay, Kwezi, welcome. Okay, so the diagonals of a parallelogram bisect each other. What does that mean? What does bisecting mean? When I say the diagonals bisect, yes, cut in half specifically. Thank you very much, guys. They cut each other in half. Did it say anything about them being equal? Did it say anything about, thank you, Sai, it didn't. So AC in a parallelogram, AC is not equal to BD. They only cut each other in half. So if BE is 4 centimeters, how long is ED? If BE is 4 centimeters, how long is ED? Thank you, Benjamin. It is 4 centimeters, right? And does it mean that AE is 4 centimeters? Let's see if we heard what I said. Does it mean that AE? Thank you. No, AE could be 2 centimeters, which means EC is also 2 centimeters. So the diagonals cut each other in half, but they are not necessarily equal. Okay. They are just cut in half. Let me use different colors so you guys get it. Green is equal to green, blue is equal to blue. Wonderful. Now let's talk about the angles, okay? First thing we need to know about all, yes, you did, Sai. All these is that the interior angle, so the angles at the corner all add up to 360 degrees. Okay, the same way we learned that in the sum of the interior angles of a triangle add up to 180, those for a quadrilateral add up to 360 degrees. Don't forget that. Okay, so the opposite sides of a parallelogram are equal. That means side AD is equal to side BC, and side AB, my handwriting is horrific, is equal to BC, and DC is equal to AB. Okay, so the opposite side, yes, side, all triangles, interior angles are equal to 180 degrees. Okay, so the opposite sides are equal and parallel. So there we go. There we go. There we go. Okay, and then when we talk about sides, the sides are all equal, right? And then one thing about angles, the opposite angles are equal. So this whole angle D will be equal to this whole angle B. And I'm running out of colors, so I'm going to just use a highlighter. This whole angle A will be equal to this whole angle C. Okay. I hope we get it. I hope we understood what just happened. I hope we can follow my color coding. It looks pretty. Okay. In a shape number 2, what's a shape number 2? What do we call that shape in number 2? Thank you. Khomoto was waiting. I feel like Khomoto typed it and waited for me to say, what is shape number 2? It's like, press enter. It's a rhombus. Okay. I knew it. It was too quick. It's like you really, really waited. Okay. In a rhombus, nope, it's not a kite. It's a rhombus. So in a rhombus, first of all, let's start with the diagonals. The diagonals, again, they bisect each other, but on top of that, they also bisect the angles at the corner. So look there. Okay, so this side of B is equal to the other side of B. They should have actually put numbers there because it's really weird to say. Okay, B1 is equal to B2 and D1 is equal to D2. In the same way, A1 is equal to A2 and C1 is equal to C2. Okay, so that's about the diagonals. They bisect each other and the angles at the corners. There we go. Now let's talk about angles. The opposite angles are equal, but we knew that because that's the same for a parallelogram. Are the opposite angles equal? Yes, side, they are indeed equal. Okay, now, as we said, you need to remember all the angles add up to 360 degrees. And with the sides, yes, they are all parallel, but they are also all equal. It's like a square. So if one side is 4 centimeters, all 4 sides will be equal to 4 centimeters. Okay, so that's one of the differences between a parallelogram and a rhombus. That's how we tell them apart. But one other thing that is very important with this is that the diagonals bisect at 90 degrees. So diagonals bisect at E. Can we see E? There's E over there. That means all the angles at E will be 90 degrees. Okay, so here's a check-in point. Parallelogram, rhombus, thumbs up, thumbs down. Do we understand all the properties we've discussed so far? Okay. I see the thumbs up. All right. Now let's move on to the last two, which are also pretty similar. Okay. My little setup is not working here. My laptop is uncooperative and my voice is leaving. Guys, do I talk that much? My voice is definitely tapping out and leaving me. Oh my goodness, it's the flu. Okay. Is it possible where the diagonals don't bisect at 90 degrees? Yes, but it wouldn't be a rhombus. Okay, Simon. So if it does not bisect at 90 degrees, then your shape is not a rhombus. Okay. Yes, it is. Isn't question 3 a rectangle? Yes, it is. It is a, of course, I'm writing with a highlighter because what? My brain is not working today. It's a rectangle. You two are correct. Okay. Now let's look at properties of a rectangle. First things first, the angles at the corners are all 90. Do you see that? Look at the blue highlighter. They are all 90 degrees. Okay, so if I say this is a rectangle, you know all the interior angles are 90 degrees. Second thing, the diagonals are equal. So in a rectangle specifically, BD is equal to AC. AE is equal to EC, that's true, but it's also equal to BE and it's also equal to ED. So specifically in a rectangle, the diagonals are equal, all right? And all the interior angles are 90 degrees. And then once again, the opposite sides are parallel and equal. Now let's look at a square. Oh, there's a lot going on there by the square, né? You can just see. There's a lot going on here. This is a square. Okay, now the diagonals bisect each other. Okay, again, it has all 90s, including in the middle. The diagonals also bisect the angles at the side. and the diagonals are equal. So the square is like a combination of all of these shapes. If you look at it, actually, a square is a combination of all of these shapes. Okay, it has equal diagonals that bisect each other, that also bisect the angles at the corners. The sides are also all equal and they're all parallel. Like square has everything. It's just boom, it's a square. Okay, now let's see if we know our properties. Okay, it's one thing to say thumbs up, but let's see if we actually know our properties. This is an exercise, and I want you guys to name a shape that specifically is true for the property. So A says the four sides are equal and the opposite angles are equal. Not all angles are equal, only the opposite ones are equal. Which shape is that? So you need to look at both properties, guys. You can't neglect one. So first, the shape, we know it has four equal sides and the opposite angles are equal. Thank you, guys. It's a rhombus. It's a rhombus, okay? It has to have both properties. All right, wonderful. Number B says a triangle with angles that are equal, 3 equal angles. Thank you so much. It's an equilateral triangle. Okay, a quadrilateral with opposite sides are equal. Opposite sides, not all of them. Opposite sides are equal. And all the angles are 90. Oh, now I'm not catching you guys anymore. You guys are getting good at this. Rectangle. It's a rectangle, guys. But there's 112 of us in here. I expect way more responses than what I'm getting, guys. Only the same 10 people are sending a message. Come on, guys. So this is a rectangle. Wonderful. Fatima, what do you mean how? Please be more specific with your question, okay? Number D says a quadrilateral with opposite sides parallel. Opposite sides, but I feel like that's all of them that we talked about, isn't it? Opposite sides are parallel, all of the above. I mean, in a square, opposite sides are parallel. In a rhombus, opposite sides are parallel. In a parallelogram, opposite sides are parallel. And in a rectangle, okay, we can't say quadrilaterals. We must say all of the above. So out of the 4 above mentioned, it is all of the above. Okay. The next one says it's a quadrilateral with adjacent sides that are equal and opposite angles. Ooh. Adjacent sides, meaning the sides next to each other, not opposite. Adjacent sides and equal opposite angles. Not all angles are equal, only the opposite ones. Yes, Sanele. Woo! It's a rhombus. Think about it, okay? The adjacent ones are equal in a rhombus and a square, right? But then the additional condition is the opposite angles have to be equal. It can actually, no, not always. The opposite sides of a kite are not always equal. The angles, excuse me. So the adjacent sides are equal. These angles are equal, that one and that one, but these ones are not necessarily equal. So it cannot be a kite, okay? Number F says a triangle with 2 equal sides. Ooh, we're waiting for this one. I got like 10 responses. Isosceles. And the last one says a triangle with 3 different angles. What is that? Scaly. Now that was a proper check-in that we are understanding our properties. Thank you guys for participating. Wonderful. Now let's apply these rules. You know, we're not going to ask you to label a square and a triangle, right? You guys know that. So let us get to why we are really here today. Okay. Now, we're going to read our information. Kwesi's like, it's not hard. It's not hard. Look at Anya. Anya's like, game face on. Dim, dim, dim. Okay. Oh, Anya Kanti is busy throwing shade. Me, I'm saying game face on. Kanti, she's busy typing shade there in the chat. See you. Okay, guys. So ABCD is a parallelogram. There's a reason they told us that. Okay, is a parallelogram. Now, I want all the unknowns. So I want W, X, Y, and Z. That's what I want. There we go. Okay. Let me do this. Take screenshots quickly, guys. Oh, woo, people already know why, guys. That was so quick. Is this Mida? Mida? Hello. Okay, while we wait for you to unmute, I see people say Y is 112. Remember?
Hi, ma'am.
There we go. Hello.
How are you doing?
I'm well, and you?
I think ACD is equal to 180 degrees as it's a parallelogram.
ACD.
So X.
Oh, X
So
is equal. Oh, Mida, your connection is not.
equals to 212 plus 42 degrees equals to 180 degrees.
Okay. Okay, Mida, your connection is not very well, so I'm not sure what you exactly said. Please type it in the chat for me. Please, please, please. Okay, we said Y equals 112 degrees, and our reason is the opposite angles of a parallelogram are equal. So opposite angles of parallelogram, that's how we write parallelogram in our reason, parm, are equal. So now we have Y, which is 112 degrees. Now, guys, look here. This whole angle is 68 degrees. Do you see that? So going from there to there is 68 degrees. And then this little piece over here is 42 degrees. So how are we going to find out W? How will we find W? Anyone? Yes, Kwezi. If the whole angle is 68 and the little one is 42, then W will be equal to the big one, 68, minus 42. And we can't exactly have a reason for this. We're just subtracting. So then W is how much? What's 68 minus 42? 26. Wonderful. So we know W is, okay, I'm going to write it down here, 26 degrees. Wonderful. I saw people give me an answer for Z. Let me go up. Saneli said Z equals 42 degrees. And Narisha, thank you. Narisha even given me a reason and said alternate angles. Okay. Z equals 42 degrees because they're alternate angles. Which ones are parallel? AC, parallel to BD. And then again, X is equal to 26 degrees. What's my reason, guys? What's my reason? Yes, Kwezi.
Hi, ma'am.
Hello.
Ma'am, how is it alt angles? Because it's not given over here that the lines are parallel.
Oh, but it
Because my
is.
teacher said that when lines are parallel. Oh, sorry. Sorry, ma'am. Sorry, ma'am.
Okay, guys, Kwezi has asked a question that I know a lot of people were wondering, and I know she figured it out as soon as I drew an arrow. Guys, that's why they told us it's a parallelogram. So we're using the properties of a parallelogram to answer the questions. I actually should have started there. What are the properties? That is parallel to that. That is parallel to that. And then what else? This is equal to that side. This is equal to that side. Okay, so you just write down the properties and then you use them. Yes, and then you use them. Okay, don't worry, Kwezi, it's a very common mistake. And then learners get stuck because it looks like a random shape and they're like, I don't know what to do with this. It's just a shape. Remember, without those parallel lines, you can't do anything with this thing. Okay, you're welcome. Okay, so X is 26 and also alternate angles again. And this time it's CD is parallel to AB. Is that everything? W, X, Y, Z. Wonderful. Here's our check-in point. Here's our check-in point. Thumbs up, thumbs down. How are we feeling about using properties of a quadrilateral to answer questions? Okay. Okay, I see thumbs up so far, but there's 100 and we are up to 117. Okay, Sai, it's confusing because there are a lot of properties, right? Don't worry, we're going to do more just now. I have a feeling you know the properties. You just need to apply them. Okay. Desets is also saying neutral. Okay, we'll do some more so that you guys feel a little bit more confident about it. Zama, where did you get that emoji? Zama's like, ah. And I love it. I'm here for it. I wish I knew where you found it. Because she's like, I'm getting there. Almost. Okay, let's do some more application so that everyone feels a bit more confident with this. Okay. Okay. What shape do we have here? Which shape do we have here? What? Which shape do we have here? I'm going to add a Y here. Okay, I'm going to add Y there. And where do you want it? Wonderful. Which shape do we have there? Everyone says square. Some people say rhombus. Square, rhombus. Parallelogram because of the lines. Okay. Okay, guys, what is the main difference between a square and a rhombus? What is the main difference between a square and a rhombus? Let's think about it. A square has 90-degree angles at the corners. We don't know if this is 90 degrees. Okay, so it's more a rhombus. I think it's more likely to be a rhombus, unless you know that those angles. But remember, guys, we don't draw these things to scale, so you can't make assumptions. It's possible that I can draw a tilted shape, so I can definitely draw a shape that is not straight at all. But if I put this there, that means that's 90 degrees. Okay, so that means it is a square. But in this case, were we given any 90 degrees angles here? In the angles that are interior, were we given any 90 degrees? No. So we can't assume it's a square, which means it has to be a rhombus. Because the main difference between the two is that in a square, our angles at the corner are 90 degrees. Okay. That is true, Emmanuel. That is true. For all the people asking, why is it a rhombus? Okay, guys, first of all, we can see that opposite sides are parallel, right? That's fine, but that's also true for a parallelogram. So that tells us nothing. Okay, see, parallel, parallel. But look at the adjacent sides. Look at this. These two marks are telling you that the sides next to each other are equal. So that means EH is equal to HG. but that's also equal to FG, which is also equal to EF. So this has to be a rhombus. So ma'am, only if it shows us that it's 90, then we know it's square. Correct, Megan. Same with a parallelogram. Okay, if you have a shape that looks like a square, a rectangle, but you don't have any 90 degree in the corner, you will just assume it's a parallelogram. You can't assume it's a rectangle until you know, or until you prove it. Okay, it's possible that you can prove that it's a parallelogram. Okay, Sai says, I'm a bit confused with the adjacent. Adjacent means next to each other. Okay, means next to each other. Is my voice breaking, guys? No? Okay. So, Sai, look here. Opposite means facing each other, right? So if I have a shape like this, opposite would mean that one and that one. Okay. But adjacent means the one next to each other. So it's this one and that one. So the ones that share a vertex, if they share a corner, then they are adjacent. But opposite means it's the one at the bottom with the one at the top, or the one on the left with the one on the right. So the condition that makes this a rhombus is that the adjacent sides have to be equal. There we go. So I understand. It's beautiful. Now, guys, I want us to work out X and Y. X and Y. We have established what shape this is. We know the lines are parallel. We know the lines are equal. What is this shape? Excuse me. Anyone have an idea? Not what is the shape? Geez, what is X? The way I said, what is the shape with confidence, all the confidence in the world. What is X, guys? Anyone? Someone? Okay. What do we know about the diagonals of a rhombus? I'm giving you a nice clue there. What do we know about the diagonals of a rhombus? They are equal. No, the diagonals, not the angles. Okay, they bisect what? You're onto something. You're going to where I want you to go. What do they bisect? The diagonals, guys. These are the diagonals, not the angles. Oh, yes, Emmanuel and Sai, they bisect the angles at the corner. So that means H1 is how much? If that side is X, then H1 is also what? X. Okay, we need to follow, guys. I have a feeling we're all confused. Look carefully. So let me write down. So we are saying H1 is also X because the diagonals bisect angle at vertex. Okay, are we all with me though? Bisect means cuts in half, Lesedi. So if that side is X, this side also means it has to be X because they are cut exactly in half. Okay. Does that mean we have to solve for X in the sum and divide the answer by 2? No. Okay. We can solve for X without dividing the number by 2. We can solve for 2X and we have to divide by 2. But if we solve for X, we don't have to divide by 2. Yes, Nipo?
Hello, ma'am. So y equals 90, ma'am.
Okay.
Because it's a rhombus, and the properties of a rhombus say that the diagonals bisect at 90 degrees.
You're a beautiful person, Nipo. You're making my night. Okay. So why is
So so if that's true, then all we have to do is just do triangles, summing triangle, angle summing triangles. That's all we have to do right there, ma'am.
Nipo, but we can also do exterior angle of triangle. You agree?
Oh yeah, we can.
Because Y is the exterior angle of this triangle over here. Can you see it?
Yeah, that is true.
90 degrees equals X plus 2X plus 15. You see that?
Yes, ma'am. Yes, I see it.
Is exterior angle, triangle. Now let's solve for x, Nipo.
So you put the 15 over, then you minus it from 90 equals 75. 75 divided by 3, and you just do 75 divided by 3.
Nipo, you know your brain works like 5 steps ahead, and everyone's probably thinking, what? Excuse us. Therefore, x is equal to how much?
25, ma'am.
Yay! Nipo has made our night. Beautiful. Thank you very much. Sai also got it right. Kwezi got it right. Guys, do you see how we are applying the properties and not just learning them? Do we see how we are applying? I think I have to would you guys like me to explain again? Let me take out all this color. I feel like it's confusing us. Would you guys like me to explain again? Woo! Wintle got it. Nice. Oh, we good. Oh, Megan says yes, miss. Okay, no problem, Megan. So Megan, we're gonna start by y, okay? Y is 90 degrees. Okay, are we all with me on that one? So then this angle over here is 90 because the properties of rhombus say diagonals bisect at 90 degrees. So we know y is 90 degrees. So if you look at this triangle, guys, the one I'm trying to highlight green, but I'm failing dismally. That triangle. Do you see that 90 degree is the exterior angle of the triangle? Do we see that? Okay, so that angle is the exterior. That means 90 degrees is equal to this angle plus that angle. Now we know that angle is 2x plus 15. That was given, right? But H1, which is this one over here, is x because diagonals at the vertex bisect the angles. So if the one at the top is x, then the one at the bottom is also x. So that's where this sum comes in. So the 90 degrees that's outside, which is that one, is equal to x plus 2x plus 15. Okay, then we get like terms together. So we leave our x plus 2x the side. 15 goes over, so it becomes a minus 15. Okay, 90 minus 15 is 75 equals x plus 2x is 3x. And then you divide both sides by 3 so that you can cancel this out. Therefore, x is 25 degrees. Ropafatso, do you have a question? I see a lot of people saying we understand. Brilliant. I love it.
Hi, ma'am.
Hi, Ropafatso.
I'm fine, ma'am. Ma'am, y is 90 degrees, right?
Y is?
90 degrees.
Yes. Yes, it is.
Now, ma'am, y is on the other side is also 90 degrees. Like
This one.
yes, ma'am. Isn't like everything 90 degrees?
Yes, it is. So did you do interior angle?
No, ma'am. But if you work this out, ma'am, then by the x also it's gonna be more than 360.
No, but the exterior angle is only this one. Remember, we're working with a small triangle, right?
Yes, ma'am.
So this small triangle. So Rapavaza, you could have said this angle that's below y is also 90, which is what you said, right?
Yes, ma'am.
This angle plus x plus this one will be equal to 180 degrees because it's a triangle, not 360. Do you see that?
Yes, ma'am.
There we go. Did I answer your question?
Yes, ma'am.
There we go. Okay, I think we're feeling a little better about this. And I love it. I love it. Okay. We have one more and then it's our brain break. One more, then it's our brain break. A, B, C, D is a rectangle. Okay. A, B, C, D is this dude over here. Is a rectangle. Oh, sorry, Molokhadi. Let me do this. There we go. You can take a screenshot. Here we go, couple of seconds. Okay. You have a brain break just now, guys. And then they say DECF is a rhombus. DECF is this dude over here who's outside. Okay, boom, boom. Whew. That was better highlighting than I've highlighted in a very long time. Now my brain's like, yeah, you can take a break now. Okay, so we have our shapes. Then they say calculate the size of E1. Where's E1? E1, F1, B2, where's B2? B2 and B1. Okay, and then we must calculate the length of AC if EC, where's EC? EC is 4. So we want to know the length of this whole diagonal from there to there. Okay, I think this is doable. I already have some ideas, but I want to hear from you guys. What do you think? Let's start with the angles. Okay, so this whole angle over here, E1 and 2 are equal to 60 degrees. But what do we know about diagonals of a rhombus, guys? Wherever you want to start, okay. Oh, Kwena has already started for us. Kwena says AC is equal to 8. What's your reason, Kwena? So let me show you how to answer these questions, guys. We want all our marks, right? So we need to go step by step. So I'm going to wrap this whole stuff out. And we're going to do there. So it says EC is 4. Thank you, Nipo. EC is 4, right? But this is a rhombus, guys. What do we know about the length of the sides of a rhombus? We're here now. Sides of a rhombus are parallel and what? Equal. Do we remember, guys? Sides of a rhombus are parallel and equal, okay? So if EC is 4, therefore FC is also 4. So then we can say FC is equal to EC, which is equal to 4 centimeters. And my reason is adjacent. So sides next to each other, adjacent sides of a rhombus are equal. Ropafazo, do you see the rhombus? Remember they told us DCF, the yellow guy is a rhombus, right? It's 4 because they told us. Look at the question, if EC is 4. Okay. So they told us, nope, you can't say what it looks like. You need to read the information. Remember I said we don't assume anything. They told us it's a rhombus, so we apply. The 4 comes from the question, guys. Calculate the length of AC if EC is 4. Do we see? Oh, we're not reading questions. There, I just highlighted it. Adjacent sides are equal as well, Rapafato. In a rhombus, all the sides are equal. It's like a square. Okay. All the sides are equal. So if EC is 4, FC is also 4. Are we with me? Are we with me? There we go. So we know now that FC is 4, EC is 4. How long is AF? Now let's look at AF. AF is this one. It's part of the diagonal. AF is how long is AF? No, guys, we're not talking about angles. We're talking about the length. Length. There we go. AF is also 4. What is my reason this time? The diagonals bisect each other. right? Because if this part of the diagonal is 4, then the top part is also 4. So if those two sides are 4, what is the length of the whole AC, guys? Therefore, AC is equal to, look where AC is. Thank you very much. 8 centimeters. And you don't need a reason for this. You just added them. Okay, so far are we with me? Nope, we're not going to a brain break, Fatima, until we do this. So far, are we with me? No, sorry, there is no reason. What you can do is show your calculation. Okay, so what you can do, you say therefore, because remember, as soon as I say therefore, it means look above and look at what I said above. And those are my reasons, basically. So those are my therefore. So if this is equal to 4, and if that is equal to 4, therefore AC has to be equal to 8 centimeters. Okay, there we go. Okay, so we've done number 2. We're done. No, it's not congruency at all. Congruency is way more complicated. We're not there at all. So now we're still here, guys. If the whole angle E is 60, all of it is 60. How big is E2? If the whole angle E is 60, then E2 is how much? Thank you, Kwezi. How do you know that? E1, excuse me. E1 is 30. What's my reason? What's my reason? Anyone? There we go. Diagonals. We need to learn our properties. Bisect angle at vertex. Okay, so we've done E1. Where's F1? There's F1 over there. What's F1? Remember, guys, you can look at triangles, you can look at parallel lines, you can look at whatever you need to look at. Palisa?
Ma'am, I wanted to ask, does it mean that because AC is 8 centimeters, does it mean that EG is also 8 centimeters?
Yes, it's also 8 centimeters because it's a rectangle.
Okay, thank you, ma'am.
You're welcome. Why is F1 also 30 degrees? Nope, it's not because they bisect each other, but there's a different reason. Yes, Nipo?
Ma'am, answer is angles of equal sides.
Thank you. It's an isosceles triangle. Angles opposite equal sides. Okay, Nipo, I'm going to stop you right there and explain first before we continue because I know you want to answer the rest of them. So guys, let's look at this triangle. Let's look at this triangle. Whoop, whoop, whoop. Remember we said adjacent sides of a rhombus are equal, right? So here's our rhombus over here. FD is equal to DE. Do we understand so far? Do we understand that part, guys? We're in triangle DEF and adjacent sides are equal. So this one is equal to this one. So that makes this what type of triangle? DEF. That makes DEF what type of triangle if the adjacent sides are equal? Isosceles, thank you, Rapafadzo. And if we just said that E1 is 30, does that not mean F1 is also 30 because it's an isosceles triangle? Isosceles, in the words of Kwezi. Do we see, guys? So we're using the properties of a rhombus. It says adjacent sides are equal. So this is an isosceles triangle, which means the angles are also equal. Are we good? We good? I hope so. We're awfully quiet, so I hope we're good. There we go. Sai says yes. There we go. There we go. Okay, so now we have worked out what? E1 and F1. Where is B2? There's B2 over there. Here is B2 over there. Anyone want to help us with B2? Anyone want to help us with B2? Yes, Nipo.
Ma'am, the whole of angle B is 90 degrees, ma'am.
Yes, it is.
Because it's a rectangle, ma'am. It's a rectangle. As it clearly stated in the beginning of the question. Yes.
So then B2 is how much?
Should be 45, ma'am.
Wow. Thank you. There we go, guys. Whew, I'm tired and I'm getting hot. Okay, and then we have B1, which you guys have now inferred. Woo, I think it's time for a brain break. I'm tired. I can't see. My eyes, I can't see. Now I'm feeling it because we've been. Okay, Fatima. Oh, is it for
Yes,
the brain?
ma'am. Yes.
Hey, Fatima, you haven't even seen what is the brain break. There we go. What is the reason? First of all, guys, the angles at the corners are, yes, there we go. Interior angles of rectangle are 90 degrees. I was about to go around and around. Angles at the corners of the house, of the double story. Yeah, you guys get it. Interior angles are 90 degrees. Okay, Fatima, let's count. How many squares are there?
5.
5. Did you say 5?
Yes.
Okay, we'll see. Let's see what everyone else in the chat says. Anya, do you have a different number?
Yes, I do. If
How
you look
many?
at the square,
Hey,
when I
Anya,
look at it,
don't explain. Just tell us how many there are.
9. Just
Okay.
look, you'll see multiple triangles in one.
I'm going to say Anya says 9. Okay, let's hear Hello. Fatima said what? 5. No? Hi.
Ma'am, there are 9.
Yee. Okay, Hello's with Anya on this. Okay, is there anyone who doesn't say 9? Ropa Fadzo?
Ma'am, I think it's 15.
Woo! Ropa Fadzo went over and above, guys. Woo! Okay, 15. Okay, let's count, guys. I think we should count. What do you guys think? If I don't find some, you guys are gonna have to help me. Okay, I'm gonna do a tally again. I'm gonna do a tally as I count. So we have the big one. That's 1, right? And then we have these 4. 1, 2, 3, and 4. Okay, so 1, 2, 3, 4. That's 5. Okay, are we good so far? Then we have these little baby ones. 1, 2, 3, and 4. Okay, 1, 2, 3, 4. Okay, so far we're with me. Then there's one in the middle here, that one, and that one. So that's 2, 1. 1, 2. And I don't see any more. So I'm gonna need you guys to help me find. People said 15. I'm gonna need you guys to help me find more. I am out of triangles. I'm out of triangles. Oh my goodness. You only see 9. There are 11. Look carefully, Sai. I feel like Sai didn't count the 2 in the middle. This one, look, Sai, look at this guy. It would be great if I could highlight a freaking square that exists already. There, 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 and there. And the one at the bottom of that one. See? It's Zama is confusing us. Bunta's like when I said 15, I was just like, Did I say triangles? Maybe triangles are haunting me. Okay, guys, I'm gonna go with 11. And our 3 people, none of them guessed it. Yo, I was gonna give you a rose. I was gonna give you a rose if you want, guys. Now I have a challenge for you guys. Next lesson, we're starting with this. I want you guys to tell me how many squares are in this one. How many squares are in this guy? Next lesson, this is where we're starting.